Greetings and welcome to Neve Engineering, and today we'll be talking about the robotics controller. My name's Keegan Neve, I'm the robotics engineer here at Neve Engineering, and the whole point of this channel and my company is to build and share information about robotics, releasing them as open source. Yeah, the primary way to follow us is on this channel. If you want to support us, then yeah, subscribe, do all the usual things you do on YouTube to feed the beast that is their algorithm. There's also I also have a Patreon page, as most people do now. Starts from £1. You get early access if you go from £5 and up, which is incredibly useful. I'll put a link under there somewhere, and if you're able to help out there, that would be great. If not, just stick around and watch. That is helpful. Right. What we're talking about today is the robotics controller that I built primarily for my PiWars robot, MacFeegle Prime. But ultimately, it's a robotics controller. It can be used for pretty much anything I want to throw at it. And that is the plan. Its kind of code name, as it were, is anything, because it should be able to control anything. And I love puns, so that's that really. And yeah, at the minute, we're just concentrating on MacFeegle Prime, because he's the only robot I've got. And yeah, so today we're talking more about how the controller is put together and how it actually controls the robot. Now, in the previous video, there was I gave a demo of how the arms work and all the rest of that. So if you wanted to watch that, do go back and watch it because it's a good video, but I'm biased. And yeah, today we're just going to go into a lot more detail on the controller. So, as you can see, it's not without things that need improving. The case itself is 3D printed. I designed that one myself. It's completely overkill. I'm pretty sure if the parts weren't in there, you can see how thick that bottom part is. I could probably stand on it without it even groaning. But yeah, it's kind of designed around the sturdy controllers you get for mobile cranes and things you get on the back of trucks. And this one has, at its core, a Raspberry Pi, because PiWars. And you can see that under there. That's just the power supply for the robot kicking in. I've got that for a while because it's got pretty full batteries. Yeah, as you can see behind there, there's a Raspberry Pi 4 with a PiJuice control hat on top of it, and that's essentially a UPS. So the idea is you can charge it. It's got a lithium-ion battery on there, and it can run the Pi. As it stands, it can run for about half an hour to 45 minutes, and then you need to plug into a supply. But if you're just doing like one of the PiWars challenges, they're 5 minutes long anyway, and worst case scenario, you can just plug it into a USB battery bank and keep the bank in your pocket and you're good to go. So we've got the Raspberry Pi and the PiJuice in there. We also have a Raspberry Pi full official display screen thing, 7-inch touchscreen. There we go. I think that's the actual words. And yeah, that isn't really doing anything other than showing my excellent logo, but you can use it to actually show live video from the cameras, and the idea is it'll be extended with other telemetry from the robot, such as battery levels and sensor information, current modes, and things like that. The meat and potatoes of this are these two chunky joysticks. Now these are 3-axis joysticks, so you've got X, Y, and also rotate, along with a button on the top of each. So they're 3-axis plus a button. We also have these gloriously chunky switches, which I love. These were taken from an old Spectrum analog RC transmitter. I wasn't ever going to use it again because it was analog and a pain to upgrade. So yeah, I thought I'd bring the switches along for the ride at least. And I've still got the gimbals at home as well. But yeah, along with the switches, I actually have this rotary encoder as well, which you can currently see lit up red. Press that, changes color. That's got full RGB in there. It's a rotary encoder, so you can change. It detects when you're changing it left or right. And it's also got a push button in there. So the idea will be that can be used for changing the speed the arms move at, for example, and it'll be displayed on screen, something along those lines. And the RGB LED will just be a status LED. It's not currently doing anything other than changing color because it's got no other features yet. These switches are hooked into the Pi via a Teensy 4.0, which you can just see in there. You should be able to see its LEDs. And basically it's listening for, well, it's measuring the values of the joysticks and the switch states, and it is in a USB HID mode, so human interface device mode. So it is currently pretending to be a keyboard, mouse, and a joystick, because Teensy's can do that out of the box quite nicely. This Teensy is in extreme mode, I think they call it. Basically, the standard mode that a Teensy is in for their joystick is, well, standard, I guess. It's a 12 versus a 64 in the settings file. I'm not quite sure the difference there, but basically, if you put it into extreme mode, you get more axes, more analog axes to play with. And I needed that because the encoder gave us a 7th, whereas as standard, you get 2 X and Ys and 2 triggers, or 2 sliders as far as the HID terminology is concerned. And yeah, so it's in extreme mode. I'll put a link to in the description to my repo for this, so you can actually see the code and all the rest. So how does it all actually hook together? We have a couple of key libraries that are involved. I've mentioned the Teensy joystick, and the biggest one is ROS, so the robot operating system. That is what actually controls and coordinates the movements and capabilities of the robot, but that is running on the controller as well. So I'll give a demo in a minute, but essentially there's a ROS master which is running on the Pi on the robot, in my case, and all of the nodes basically talk to that master node controller. I'm just going to call it controller because I don't like the master terminology, but so they talk to that controller, the main controller in his head, and it coordinates the messages sending out via the various subscriptions and topics and all the rest. So the bit that hooks them together is Tom Oinn's approximate engineering input library. I'll put a link to the description to that as well. And basically, Tom's written an absolutely brilliant library that inputs input from generic controllers and lets you use it in a Python script. He's also wrote from scratch a new version of the Redboard library that is running in MacFeegle Prime's head, which allows for the control of the arms and all the rest of it. So he's a PiWars competitor of many years who's very much given back to the community, and definitely appreciate that, Tom. And yeah, that's the bit that kind of goes between hardware and software. And I'll give a demo of that now. Right, switch to Tom Oinn and video. Right, so here we are in an SSH shell terminal, whatever, on the controller itself. Now, part of the approximate engineering library that Tom added recently is the profiling tools. So I'll just give a quick demo of that. So you install it using pip, and there's again more information on Tom's page, and it'll be more up to date on the off chance it changes. But essentially, you install it, and then you have a bunch of helper tools as well. One of which is a proxeng input profiler. Run the profiler, and if you've got multiple devices plugged in, you're asked to select which one. Now, I know from trial and error that number 1 is the joystick. Now, I think 0 must be the keyboard and the mouse, because like I said, it's a composite HID device. By running this tool and selecting the input, you're then basically given all these things. It flickers for me as well, so that's not the video playing up, that's just how it is. Not sure why, just is. So what we can see is we've got under buttons, we've got circle, and if I toggle the various switches, then you can see that being picked up by the profiling tool. So what that's doing is saying, right, the only actions I've just detected are on event ID 289, which corresponds to this switch in this case. So that's the one I'm going to use for this value. And you can go through, and there we are. So now we're on left X. So if we do the left X one, that'll detect that you've moved that along with the maximum and minimum values. Why that stayed at 0. And, oh, 0 is the ID of that axis. That's fine. Right X, the same there, and so on and so forth. Now, when you've gone through and mapped all of these, when you exit, you'll find I exited it wrong, didn't I? Right. So yeah, this time around, if you do list the files there, you'll see this Tinsiduino serial blah 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 file. Now, if you create a .approxeng input folder, and if you put that file into that folder, then anytime you plug this same USB device into this machine, it'll detect that mapping and allow you just to use it off the bat, and which is incredibly handy. The other thing about that is that if you've got multiple controllers, so for example, I've got an Xbox One controller around here somewhere, you can map those buttons to the same functions from the perspective of approxeng input. So if I was using this controller to control the arms, I could have an Xbox controller, plug it into there, and someone could be driving. So it's kind of handy the way it gives you that extra abstraction layer. So again, Tom, thank you for that. So what we need to do in order to get everything tied together is actually bring online all the various nodes and whatnot in ROS. So we've already profiled the joystick, so we know that works. And what we can do now is bring everything online. So what we need to do first is bring up ROS core. So in a window in Tmux I'd prepared earlier, we can just type ROS core, and because of the way everything's already configured, it'll just start running. What we can then do is go back over to the controller, and if we do ROS topic list, we can see what topics are currently available. And that's just the basic ones. So if we now do ROS run any joystick, joy_node.py, that'll actually start the joystick node running. And we can, all it'll do is just give us a cursor. So if we start up a new terminal and do ROS topic list again, we should see we've now got the joy topic. And if we echo that, this might flicker a bit on the screen, so FYI. Yeah, we've got the joystick commands, and I'm wiggling a joystick and getting different numbers on the screen. The joystick is now broadcasting, this is my state, this is my state. And that's it. Now what we need to do is have something on the robot listening for it. Now in this case, we switch to different pane again. So this is back in the terminal on the robot, and do ROS run MFP core ARM node. And there we go. So as you possibly heard there through the microphone, his arms were initialized and is now ready to go. So what we can see now is that if I put it into ARM mode, you can see his arms moving. And I gave a full demo of this last time, so I'll not go into too much detail this time. I'll have him wave at the screen again, because that's a nice party trick. One of many. But yeah, so that's kind of how everything links together and how I actually bring the robot online. What we can also show is we switch back to this view where we've got the ARM node. If we create another one and do ROS run again with MFP-core, and this time running the head node because I'm not daft enough to start the motors while he's sat here, it will throw an error because I'm not currently running Pig Pilot. The head node runs from the red board in his head, and if the Pi GPIO daemon isn't running, his head won't either. So yeah, as you can see, when I move the joystick around, we're actually controlling his head. And when I switch this switch from down to up, that actually switches from motor, drive and head control to arm control. So this is an example of how we're broadcasting one set of messages from the controller, which is this is the state of the joysticks, and depending on the state of those switches, the receiving nodes will act accordingly. So in this case, there's basically if switch 3 dot on, do motor control and head control. If switch dot 4 on, do arm control instead. So once you get down to it, it is as simple as that. It's just all the plumbing in between that's a bit trickier. So that is how it all ties together, and it currently works. But obviously there's still more to improve, because there always will be. I am firmly of the opinion that this is, what's the phrase for it, my dear friend? Nope, that's the wrong one. My dear friend Steph introduced me to is perfect is the enemy of done, and this ain't perfect, but it is done. So we want to make sure that this can support itself and have different, like some way of it holding up, so that if I'm sat down on a desk, I can have it flipped up like that and it's easier to see the screen. But if I'm using it like this, it's flat down. Obviously the back needs tidying up, and we need the power and switches and charge ports enabled. Those are just a few of the things to improve. I'll be going into more detail in a future video about an update to Tom's library that we've been discussing, and where at the minute I'm using one of the trigger axes for the encoder, the Rotary Encoder, that basically causes a bunch of problems under the hood. So he's adding the ability to add generic axes, so you can customize that a little bit further. So I'll go through that again in more detail to show how that works when that's implemented, basically. So until then, if you would like to support me on Patreon, I would greatly appreciate it. It starts from £1. £5 users get £5 and above patrons get early access to videos, and 15 and above, which are currently my parents, thanks folks, they get their names at the credits of the video as well. So yeah, it's just a great way of helping me out. Like I say, everything's going to be free regardless of you supporting me or not. And I know times are tough on 7 ways from Sunday, but so yeah, it's always going to be free. It's just there might be a bit of a lag. That just seems fair, really. So yeah, URL down there somewhere probably, and this accursed video is finally done. There's probably going to be bloopers in the credits, because this has been hell. Not because of the libraries or anything like that, just little problems that cropped up everywhere, because I'm not going to swear, but I would like to. So stay tuned for those. Stay tuned for more info. The next task I'll be working on is actually bringing the sensors online. I've actually already had a bunch of success using the stereo cameras in his head to a Google Cardboard headset or a Deferi VR virtual glasses. And yeah, it was weird, but very cool, especially when I turned the corner and saw my reflection in the mirror and it was the robot. That was a bit freaky. But yeah, more information on that in next week's video, hopefully, if hell doesn't explode again. This one has been a pain. But yeah, thanks for watching. If you've lasted through the madness this far, take care of yourselves and hopefully see you for the next one. Bye for now. My name's Keegan Neve. I'm getting started is a worse. Once I'm started, I can just waffle for hours.